What's going on, guys? Welcome back to this video. Today we're going to talk about some of the ways we can follow to exploit Docker containers vulnerabilities, or in some words, to assess the security of Docker containers. Now, in the previous videos, we presented introduction about Docker containers. We talked about containerization, how it's different from virtual machines, what are the benefits of using Docker containers, and of course, we presented and explained how to build, configure, and run Docker containers. Now, the previous videos are considered as an essential building block or an essential unit if you want to take it further and pen test a Docker container or do security assessment for Docker containers. Everything we talked about in the previous videos are essential, so go back to them if you haven't watched them, and if you're ready, you can proceed and watch this video. Today we're going to talk about some of the methods we can use to assess the security of Docker containers. Now the first method is Docker registry exploitation, and the other method is Docker images reverse engineering. Now there are multiple methods we're going to talk about, of course, but today I'm going to talk about two of these. Now the objective of reverse engineering Docker images, or the objective of exploiting Docker registries, is to obtain sensitive information. These sensitive information can be credentials, passwords, configurations that might be used while creating the Docker. So we learned previously, while we create Docker, we create something called the Docker file, which contains the instructions that the Docker will execute once it is run. Now this forms the Docker container image. So when we exploit the Docker registry or reverse engineer the Docker image, we aim to look for this information inside the Docker file or inside the Docker image. We want to see if by chance or somehow credentials or passwords have been used while running the container. And not only password or credentials, we can also gain insights about the environment configuration, because the commands or the instructions used in the Docker file are actually revealing to the environment that the Docker container was running on. So you can consider this phase as part of an information gathering phase or the scanning phase in your pen testing. You figured out that there is a Docker container running and you want to gather as much information as possible about the configurations, and therefore if by chance you can take a shortcut to a shell or some admin panel by revealing credentials or configurations. So Docker registry exploitation. Of course, don't forget that I'm going to put a practical scenario after explaining the concepts. Now, Docker registry is a place where it contains repositories for the Docker images. So essentially, when we download a Docker image, we download it from a Docker registry. Now, Docker registries are so many of them online, from which you can execute the command docker pull. So docker pull downloads a Docker image. A Docker image is downloaded from Docker registry. So when we exploit Docker registry, we aim to reveal all of the images contained in that registry along with the versions, and eventually we aim to reveal something called the manifest file. So the goal here is to reveal the manifest file. Exploiting Docker registry is grabbing the manifest file. The manifest file contains information about the application that's running inside the container. The information can be the size, the layers, and the history section contains a wealth and plethora of information about the environment on which Docker is running or was running. So that's the objective of enumerating or exploiting Docker registry. Now the other thing is the Docker engineering or reverse engineering the Docker image. So when we reverse engineering the Docker image, we essentially reveal all of the details about the instructions that the image is running on the environment. This also reveals information about the environment, the users, passwords, etc. We're gonna talk about this in the practical scenario. So let's first start with the Docker registry. All right. So the first thing here, I'm using TryHackMe as a practical scenario for this video. Okay. Now, as a requirement to successfully complete this room is to add the IP to the host file. So let's take the IP and we say nano etc hosts. We add the IP address, and this is the host name. And we also need to add this entry to the daemon. So nano etc docker okay. So we add this. This allows us to interact with the container on the ports it's using. Alright. So the configurations are done. Now let's restart the container itself. Docker, okay. So essentially, guys, the containers are running on the target, on this IP address. We're using the attack box to perform the enumeration. And then we're going to restart again. Okay, let's see now if the Dockers are up and running by conducting an nmap scan. Nmap scan, we want to make sure that the Dockers are running. So basically nmap, and this is the IP. I'm going to use port 5000 and 7000. Since these two ports are used by the Docker registry. So when a Docker registry is running on a machine, these two ports should be open by default, although they can be changed. Let's see if the ports are running on the machine. So they are open. 7000 and 5000 are open on the machine, which means that the Docker is up and running, and we can now start enumerating the Docker registry. Now to enumerate the Docker registry, guys, we use a tool called Postman. So Postman allows us to interact with a Docker registry. A Docker registry is a JSON file. So the only way to interact with it is to query the file. That's how we query it. We send GET requests to the Docker registry. Okay, let's see here. So first we send a GET request to retrieve all of the available repositories. Remember that the Docker registry is a place that stores the repositories. The repositories contains the Docker images. That's how we download them online. That's a reminder. All right. So now we have the tool up and running. Create a request. All right. The first request will be, let's take this one. We put the request here, and we change the parameters. So we remember that the domain name was Docker THM. And remember that we have two ports, 5000 and 7000. So /v2/_catalog will reveal all of the current repositories on this Docker registry. Send. As you can see, we have three repositories: my app, challenge, and example. Now, every one of these repositories contains a Docker image, which we can download. For example, if you go back now to the terminal, open a new terminal here. Let's say we want to use one of these Docker images, which is the first step in building a Docker container, is to build the image. So we either build it from scratch using a Docker file, or we download it online. So say we now know this, so Docker pull, and then the domain name is this, okay, /. So we go back and check out the name of the, looks like I closed the tool. Okay, oh, all right, not Firefox, okay. Not responding. Let's go back to the tool. Okay, so say I want to retrieve this, the image inside this repository. So I'm gonna copy the name and go back to the terminal and put it here. What's gonna happen now? It's gonna retrieve the image. This is just an example, guys, to remind you how it works. Response from daemon, connection refused. Let's make sure we wait. I think I know what's happened. So they are added both. Let's make sure the IP address is correct. 179 docker rodeo.thm. Everything looks fine. Alright, okay, that's not part of the challenge, but anyway, let's go back now. As you can see now, we were able to pull or retrieve the list of all the repositories. Now, if you want to retrieve or interact with these repositories, we want first to display all of the available tags. The tags, as we mentioned earlier, are indications or variations of different versions of the same image. So let's list the tags. So let's copy this command and we're gonna open a new tab. So how to do that? First, let's copy the URL. And what we're going to do, we're going to choose what is the repository for which we want to retrieve the tag. So let's say this one. So we copy it and replace underscore catalog with the name of the repository. /tag/lists. 404 not found. Tags list. Tags, not tag. Again, we got 404 not found. See what's the problem. Let's do it here one more time. Okay. Dive challenge tag list, not lists. So send, and now it works. As you can see, the repository /dive/challenge contain one image, and the version of this image is latest. So it contains one version. This is the tag of the Docker image. Okay, and you're going to need you need to, as we said earlier, to put the tag with the image if you want to download this using Docker pull. So Docker pull the path and then the name of the image, dive challenge, and then we have 2-column latest. So that's what we missed actually here. So here, to pull this image, we have to use the tag. So latest. Now again, we get this. Not sure why we are receiving this. Let me check the help here. Somehow they mentioned that this error can happen and there is a way to solve it. So here There is no mention of this. Oh, okay. If you are receiving this, you need to revisit step 1 in the first task of this room and then restart the computer to ensure Docker has properly restarted. So that's what exactly happening with me here. But here I'm getting connection refused, not server, not this one. Okay, let's do that. And then start. Let's try to pull this, and we're getting the same. Okay, it's not required, guys, to do this because if you want to answer the question, this is not required. But we're going to try this later. Let's go back now. Alright, so the next step after we have retrieved the list of the repositories and the tags for every Docker image, now it's time to retrieve the manifest file. Retrieving the manifest file is simple. We just have to use manifests in the URL structure. So the name of the repository, it's here, and then we say manifests slash and the tag here is latest. This should retrieve us the manifest file, and indeed this is the manifest file. Take a look at the manifest file. It contains all of the information about the application, the architecture, the tag, the name of the image, some hashes, and here you can see the history section. The history section contains a plethora of information about the environment. As you can see, we have domain names here. You can scan them as well. We have, let's see here, description about a vulnerability, CVE, that got exploited somehow. Architecture, the hash of the image. So you see here, guys, a plethora of information. As you can see, guys, the CMD, the commands that have been executed while building the image. These are the commands that got executed, as you can see. And here information about the compatibility. So these information, this is because you don't see much information because this is a demo scenario. But in a fully production environment, you will see a plethora of information. Alright, so there is a scenario here. Let's go and answer a few questions. So here you want to interact with the container running on the port 7000. So we're going to execute the same requests, but on port 7000. So instead of 5, we're going to use 7 and retrieve the current repositories. So we have one, secure solutions / web server. Now let's do the same and interact with or retrieve the tags. So secure solutions / web server / tag / lists. I guess it's tags. Alright, so this repository contains an image, Docker image that has the tag production. Now again, if you want to retrieve the manifests file, we're going to have to obtain this. Okay, so we obtained the tag name. Now we can go back and say manifests / production. And we get the manifest file. Scrolling down to the history section. Let's see what we got. So architecture is AMD64. And this is the environment variable path. This is also useful from a pen tester point of view. And let's see here. The commands that got executed. And we have credentials, username admin and password production. So this is the kind of information we aim to find when we enumerate Dockers this way. We aim to find this is the information that have been used while building the container. And we have a directory here, the path to the database file. Yeah, so by taking a look at this information, we'll be able to answer the questions here, all of them. Now let's go back and explore the other methods of enumerating and pen testing Docker containers, which is interacting with the Docker image. So let's close Postman, close all the terminals, and then go back here. Let's clear. So in the next few questions, you're required to do some reverse engineering on the Docker image. Okay, so for that reason, we have to download the image. Okay, so the image that we need to download, it's let's see, what is the image ID? The challenge, for the challenge, pull the challenge image using Docker pull and apply what we have done for the questions below. All right, so let's now download one of the images we found online. This time worked because it fixed some error in the commands. Let's go back to the command I used. Yeah, so that's my problem, or that's the mistake we committed. So here we didn't mention the port when we tried to pull the image. So in the last command, we are pulling the image dive slash challenge. We saw this image earlier, right? You shouldn't forget this. And now it's on the machine. Now to find the ID of the image, we can use Docker images. And we can, as you can see, display all of the images we have on the machine, including the one we recently downloaded. This is the tag of the image. Why latest? Because that's the only tag associated with that image. If there has been more than one tag, we would have needed to specify the tag in the command. Otherwise, it wouldn't work. So it retrieved the only sole tag on this repository, and that's the image ID. Now, in order to reverse engineer the image, we're gonna need to use a tool called dive. So let me copy the link and show you guys the tool dive. Alright, this is the tool, and dive is used to display the details about a Docker image. So, and discovering all the layered contents. You can install this tool depending on the operating system you use. For Ubuntu, you just use wget to download the package, and then you depackage with this command. Once you do that, you'll be able to run the tool. So let's go back and run the tool. So dive, and then we use the image ID. We have to install it. All right, let's go back and see here installation instructions. So I'm gonna need to go back to the link because I have them in my notes. And then we depackage or install the package. Once we finish the installation, let's switch back to the command and run dive. And now it is running. Alright, so this is the view we get. As you can see here, we have different interfaces or panels. The first panel is the layers panel. The second panel is the current layer contents, and lastly, the layer details. Also, we have the image details. But most importantly, we're going to work with these three layers. Layers, current layer contents, and layer details. All right, the first layer here, layers, displays all of the commands and instructions that the image or the Docker image we have just downloaded contains. So it contains 1, 2, 3, 4, 5, 6, 7 layers of commands and instructions. It's useful to take a look at all of the instructions the image is trying to execute on the machine. Now on the right hand side, the current layer contents contains the contents of every command on the host. For example, If I want to switch between the panels, I use the tab. So I use the tab. As you can see, it's switching between the panels. Okay, with the arrows up and down, I can go up and down between the commands. So the first command here, from, and we have this, specifies, as we said earlier, the operating system or the image it's using. If I use tab, it's going to navigate to the second layer. As you can see here, the last row is changing when I press the tab. So now I'm on the other panel, current layer contents. So if I want to see the corresponding contents on the host operating system when I'm on this command or in this layer in the Docker image, what I'm going to do, I'm going first to, as you can see, space collapse all directories, because now it's expanding on the binary directory. If I use now control space, right? If I switch back to the command, one more time back here. Wait, okay. All right. As you can see, I see the contents on the file system. Let's check out the other one. So the other command here, as you can see, shows you the contents on the file system. And we can see here, guys, that a couple lines have been highlighted: the etc directory, the spin, user, and var. So it means it's using contents from these directories on the file system. All right, using tab, now we get back to this layer here, scrolling down. The third command, as you can see, contains or has associations on this directory on the file system. I can expand to look at the contents using space. The space displays the contents. Okay, back here, as you can see, we get different colorings depending on the layer I'm using on the layer on the left. Okay, so we have this command and we have the home directory highlighted. Let's go back, let's go up on expand the home directory. All right, so here, because it's adding a new username, and here is the corresponding contents for that username. All right, let's go up. Let's see if we have something else about the, wait, let me, okay. And then going back. Okay. etc. Let's see if there are some other associations with the home directory. The first layer doesn't have, the second one doesn't have, third one doesn't have, the fourth one doesn't have. Now this command has contents on the home directory. We saw it was the user. This one doesn't have, and the last one doesn't have. All right, apart from the contents we can see for every single command, as you can see, guys, it reveals in the layer details, we can see detailed information about every single command. For example, the last one, it echoes username and password, the password of the root user, as you can see here, right? And the command above this reveals the new user that has been added along with its password. That's the benefit of reverse engineering Docker images. Now, if you were able to successfully do that, you will be able to answer the questions. So 7 layers, that's the image ID, and that's the that has been added. So that was it, guys, for today's video. In the next upcoming videos, we're going to talk about more Docker vulnerabilities and more content on how to assess and pentest Docker containers.